We want to talk about the definite integral again, and this time we want to do it in a context. A person takes a job with initial salary of $28,000 per year. The contract states that there will be a 2% per year increase, and that would be 2% of what you made the previous year. Then we can calculate the salary by the formula given here. S of t is 28 times E raised to the power 0.02 or 2% times t, and the units would be in thousands of dollars. If you stay with this contract for 30 years, what will your total earnings have been over that time? And I think we'd ought to draw a diagram. So this is a straight line, that's my vertical axis, there's my horizontal axis, time, and salary. Now the salary function would look something like this as we get out toward 30 years starting at 0 years. And you can see that if this was, don't hold me to a scale here, if this was a period of 1 year, this is how much we'd be making. And so what we'd earn in 1 year would have been the width times the height, or this area. That's not real profound. Now, if we look at another year, our salary has gone up a bit, so the height is a little bit different. The width would still be 1 year. What we would make in this year would be 1 year times the salary. Again, it's width times height. And what we would have made in 2 years would be the value of height times width plus the value of height times width. So this would be the total earnings in 2 years, and that would just be an area. And so I think that we could reasonably conclude that something like the width times the height, but we're going to have to be changing the heights from time to time. If I would calculate those and add them all up, I would know what the earnings were over the 30-year period. Well, in fact, it would be the area under this curve that we're talking about, and this is your salary curve, which we'll call S of t. So it's really the area under the salary curve between 0 and 30 that would answer the question. That is, it's the definite integral from 0 to 30. And what is the salary curve? It's 28 e to the 0.02 t dt. So it looks like that definite integral should answer the question. What will our total earnings be over the 30-year period? And we know from the previous video and from reading our textbook that this is going to be any antiderivative. So I can take an antiderivative to 8, and the e to the 0.02t would be e to the 0.02t, and then divided by 0.02, and that would be the antiderivative. I'm not going to add a constant because I'm just going to use the constant 0, since I know the definite integral will work just the same no matter which antiderivative I pick. I'll pick the easiest one, but I do have to evaluate this between 0 and 30 if I want the earnings over 30 years. So this is going to be my 28 e to the 0.02 times 30 over 0.02 minus 28 e to the 0.02 times 0 over 0.02 is equal to, well, this is going to be e to the 0, so that's going to be a 1. So this thing goes to 1, and I'm going to have a 28 over 0.02, and here I've got a 28 over 0.02. So why don't I factor those out, 0.02, and I'm left with e to the 0.02 times 30 minus 1 is equal to, and if we do the arithmetic, we will find that the answer would be 1150.97. Remember, that's in thousands, and so in dollars this would be $1,150,970. That sounds like a lot, but in fact it's not very much for a lifetime's earning. All right, we'll return in the subsequent video. Thank you.